Hello everybody, my name is Cesar Leandro Londoño Calderon and today I'm going to present you to our last work entitled Mesoporous silica nanoparticles obtained from rice husk and their use to remove methylene blue from aqueous solution. Here we obtain silica nanoparticles from the incineration of rice husk, a chemical treatment of the hash, and a mechanical ball milling. The size, shape, specific surface, and cluster size of the nanoparticles were determined. The mesoporous and high specific surface area is taking advantage of methylene blue removal of aqueous solution at 2 ppm of concentration. A design of experiments was optimized to evaluate the effect of factors such as nanoparticle mass, reaction time, and temperature. Water is a fundamental part of sustainable development and essential for food and production, socioeconomic development, healthy ecosystems, and the very survival of human beings. The reuse of water as a vital and limited resource is an aspect of relevant importance due to the fact that the increase in the world population generates an increase in the demand of water resources so that communities have enough to satisfy their needs. Recently, the General Assembly of the United Nations recognized the human right to water and sanitation, where it ratifies the right of all human beings to access a sufficient amount of water for domestic and personal use. In addition, safe, acceptable, and affordable access must be guaranteed, that is, that the cost of water does not exceed 3% of household income. To guarantee this right, the availability of water is sustainable management and sanitation for all may ensure this latest aspect is the most critical due to the increasing pollution producing water effluents related to current technology development. Organic pollutants comprise an important class of pollutants generated by different types of industry. These pollutants cause serious problems in water courses due to their high toxicity for living beings and decreased penetration of sunlight. One of the main polluting industries is the textile industry, and the absorption process has shown good performance in removing dyes present in water. However, to carry out this treatment process, large financial capital is required to carry out a correct wastewater treatment. Adsorption is the process of transferring a target substance from a liquid gas phase of a system to the solid liquid surface of the adsorbent. Adsorption is considered an effective, economical, practical, selective, and environmentally friendly technology for water treatment. Among all the known adsorbents, silicon nanoparticles have been considered promising nanoadsorbents due to their particular characteristics, such as low cost, simple synthesis, low environmental damage, stable structure, high specific surface area, and porosity. Adjustable pore size and volume. This type of nanoparticles can be obtained from rice husk, which is an agro-industrial residue that is generally wasted or incinerated to get out of it. By 2016, Colombia became the largest rice producer in the Andean community and the second largest rice producer in South America, producing around 3 million tons of rice in 2017. Most of the waste that arises from the rice production is not being used in the best way. Production of the rice husk to hash, it was washed for 4 times with distilled water to remove impurities and contaminants, and it was left dried in the oven at 100 degrees Celsius for 3 hours. Subsequently, it was taken to the oven where the temperature was raised at a rate of 5 degrees per minute until it reached 500 degrees Celsius, and it was kept isothermal for 1 hour to eliminate organic material. The temperature was increased until it reached 700 degrees Celsius and it was kept isothermal for 1 hour to increase the amount of silica by reducing the carbonaceous materials. The hash obtained was subject to a chemical leaching process that allows the chemical reaction between the acid and metallic impurities. Then, these reacting metals are leached from the acid solution by washing with distilled water and filtration. For every 15 grams of hash, 252 milliliters were added to 1 molar of hydrochloric, nitric, and sulfuric acid, respectively. The mixture was magnetically stirred for 1 hour at a temperature of 90 degrees Celsius. The resulting paste was washed 5 times with distilled water, filtered and dried in a conventional oven at 100 degrees Celsius for 3 hours. After the leaching process, a white powder with a high content of silicon oxide is obtained. For the preparation of the silica nanoparticles, the GR Drive 2-liter planetary ball mill was used, equipped with a high-density aluminum drum, and spheres of 8 mm in diameter were used as grinding medium. The ball powder ratio was 20:1 and the test was done at frequency of 600 revolutions per minute for 3 hours. A factorial design of experiments from 2 or 3 to evaluate the effect of different variables on methylene blue absorption by silicon oxide nanoparticles obtained from rice husks for a methylene blue concentration of 2 ppm. For this, 2 levels and 3 factors were used. The working factors were absorption time, solution temperature, and nanoparticle mass. The work levels were high 1 and low -1. The explanation of each one of the levels, their respective factors of the experimental design, is shown in table. Each experiment was repeated 3 times to have reliability in the measurement taken, having a total of 24 experiments carried out. The results obtained by differential scanning calorimetry and thermogravimetry, which are not shown here, it was possible to determine that between 150 and 450 degrees Celsius, the organic matter of the rice husks was released. Above 550 degrees Celsius, silica-rich ashes were obtained. From X-ray fluorescence, it was determined that effectively up to 98% of the samples was finally obtained after thermal treatment and leaching correspond to silica. Most nanoparticles have a spherical shape with a diameter between 14 and 28 nanometers, which form agglomerates with size ranging between 123 and 557 nanometers. The nanoparticles obtained under this condition have a specific surface area of 148 square meters per gram according to VET results. The optical absorption spectrum for methylene blue samples at different concentrations were recorded. The maximum observed absorption is around 664 nanometers and it is in agreement with previous reports. From the figure, it's clear that the absorption spectrum is proportional to the concentration of the dye. The concentration of the methylene blue solution as function of the absorbance value at 664 nanometers was also recorded. From this adjustment and by means of linear regression, the equation that relates absorbance to concentration was obtained. With this equation, the concentration value of an analyzed sample can be predicted 99% based on its maximum value of absorbance. An analysis of variance ANOVA was developed to evaluate the influence of variables such as time, temperature, and amount of nanoparticles for the removal of methylene blue in aqueous solution with a dye concentration of 2 ppm. For this, a factorial experiment design of 3 factors with 2 levels was developed. The resulting optical absorption spectra of the supernan obtained after performing the absorption experiments were obtained. For comparison, the graph shows the spectrum for the methylene blue solution at the initial concentration. From the figure, it's clear that in all cases, the decrease in the absorption intensity of methylene blue is due to the surface adsorption of the silica nanoparticles and their separation by centrifugation. Furthermore, it is clear that in all cases and regardless of the factors and levels, the nanoparticles adsorb more than 99% of the contaminant on their surface. For this reason, from the results, it can be concluded that the treatment with 10 mg of nanoparticles for 10 minutes at room temperature is sufficient to remove more than 99% of methylene blue in solution with a concentration of 2 ppm. Thank you very much.